This video shows you how to create like those transformers for your future projects. You cannot buy them because they are obsolete and difficult to be found, except from some Chinese websites, but with very low quality, which will cause your projects to fail. The vintage radios use transformers in their audio circuits. It is called Class B push and pull transformer audio amplifier. There are two transformers at the audio circuit. T1 located near the input signal first stage and T2 located at the output and connected to the speaker. This is a schematic for an audio circuit where you can see T1 comes after first stage amplification and T2 is connected to the speaker as an output. T1 and T2 are different from each other in terms of wires, windings, and number of turns. I made those schematics to help you test your transformers after you create them. I will make them available for download. You will find them in the description box. This video explains step by step how you can create very high quality, very small transformers. Okay, those transformers are all made by me here in this room. And they are actually better than the factory-made ones. Let us prove that by comparing them with the factory transformers. Let us see that in action. This is the audio circuit of Panasonic radio R218D with the original transformers. Let's breadboard it and put it onto operation. Here we go. The Panasonic radio amplifier circuit is running perfectly nice as expected. We will replace its transformers while running with our custom transformers, and we can see the result on the output audio. So as you have seen, guys, we made very high efficiency audio transformers. Now it is time to see how did we create them. Let us go ahead and apply the following steps. Now we have all these samples as sources of wires. Definitely we are going to use some of them. Those wires, for example, are going to be used for the transformer number 2, which is connected to the speaker, but out of them we are going to use only those samples because they are exactly like we want. 30 centimeters equals to 1 ohm, which is, this is the G, this is the name of the sample, GY, and this is sample Z, okay. 30 centimeters equals to 1.2 ohms, and we are going to use this and this also, okay. Now, this one here, we're going to use this one and this one also for the two transformers. This step is not required. It's about tools that might be needed in winding the transformers. So I created some tools to help me and facilitate my work. I am going to explain them so that you can understand what I'm doing when you proceed on with this video. But they are optional, as I said. I created this holder with two attachments to be installed to it. An axis that helped me to pull required wires from transformers, and a revolver to help me measure required length and to load all required wires on it. I divided this revolver into two sides with separator for primary and secondary wires. I will pull them from power transformers and deposit them here on this revolver. Then I will use it to build my own audio transformers. So I should know, for instance, how many turns I need to pull 17 meters. And this is easy because the diameter of this revolver is known, and through certain calculations that I made, I can calculate how many turns I need without the need of measuring each wire. This will help me a lot. This is also another optional simple tool to mechanically wind my transformers in a more aligned and effective way. Also much faster than using manual winding.